In this video, we are going to talk about special exponential limits. Let's start with the form of the special limit that we are going to talk about. This is in the form of e to the x minus 1 all over x as x approaches 0. If we go ahead and evaluate right away the x's in the given function with a value of a which is 0, we get the following. The answer would be indeterminate or 0 over 0. Hopefully, with the many topics that we've already talked about in limits, you would be able to see that there is actually a pattern. When something is indeterminate, there's something that we can do to find an exact limit, right? So here's what we're going to do then. All right, so let's go ahead and look at the graph of the special exponential function that I shared to you a while ago. And as you can see here, the blue curve that you see here, that's e to the x minus 1 over x, and the red dot that you see there is really a point that would trace the points on the exponential function, the limit. And this is how it looks like. Now, notice what happens to the point as it reaches x is equal to 0. When x is equal to 0, the point disappears. Now, why is that so? Now, remember that when we evaluated the function at x is equal to 0, the function becomes indeterminate, not undefined, because if it was undefined, it would have been an asymptote. But because it's indeterminate, it becomes a whole. Now, remember in your discussion for general mathematics, there is such a case where you get to have a whole in your graph, probably in piecewise functions, or probably in rational functions, right? So this one here is almost like a rational function, but really like the main, or like the numerator here, is not rational, but it's exponential. That's why we treat it as a exponential function, right? So take notice though of the behavior as it goes closer and closer to 0, and you would see where the value of y seemingly goes to. Okay, so to make that clearer, let's go and look at this example here. So these are the points, as you can see here. The x values that you see here are x that are going closer to 0 from the right, and these are the values that are that are going to 0, closer to 0 from the left. That's why it's all negative here. And look at the values that you see here. At 0, they both become indeterminate. But let's look at the values that we see here, and where are they going closer to anyway, right? Now to again visualize that, let's have this here. So the points that you see here, so x and y there, corresponds to the x and y to the table that you see here on the right, and you would see that it would actually, the left-hand limit and the right-hand limit would actually converge to a specific y value. Remember, when we talk about the limit of a function, we are looking for the behavior of the function. When we say the behavior of the function, that's the value, the y value to which the function is going closer to, or like the y values in the table of values that we see here. And as you can see here, the values are going closer and closer to 1. So therefore, e to the x minus 1 all over x is equal to 1. Now, we did not do any algebraic way of doing it, but as we can see through the table of values and through graphing, we were able to identify that the function would seemingly go to 1, even if we know that if we evaluate x is equal to 0 for the given function, it becomes indeterminate. Okay? Now, all right, so now how is this useful anyway? So let's have this one here. Remember that if ever we have e to the x minus 1 all over x as x approaches to 0, that would always be equal to 1. And if you have e to the x minus 1 all over x as x approaches to positive infinity, as you can see, or as you could recall in the previous graph that I showed to you a while ago, kind of look like an ordinary trigonometric, sorry, not trigonometric, but exponential function. As we make the values of x bigger and bigger, the value of the function itself as a whole becomes bigger and bigger, and so therefore it goes to positive infinity. On the other hand, as we approach x is equal to negative infinity, though, what happens is that it goes closer and closer to the horizontal asymptote that we have for the function. And if you could recall in the graph as well, that is actually 0. So therefore, basically, out of the three here, this is like what we're going to always use because it would come out if we are going to talk about derivatives of exponential functions in the next chapter of our lesson. Right, so let's have a quick recap here. What if, for example, we have what is the limit of 3 to the e to the x minus 3 all over 2x? So uh, we might instinctively go ahead and evaluate right away, but what happens is that it becomes indeterminate still. So therefore, you shouldn't go for that. So what we're going to do is that we're going to look at specific, like we're going to use the previous special limit that we know, where we know that e to the x minus 1 all over x as x approaches to 0 is equal to 1. As you can see here in the numerator, we can actually factor out something that's common between the two terms that we have here. So this is the first term, second term, and there's something common, which is 3. And so we go ahead and factor that out from the numerator. And we can go ahead and factor out 3 halves here, because those are the multiples of the numerator and denominator. And if you can recall, if we have a function and we multiply it by a constant, we can actually factor that out from the limit itself. And as you can see here, this should be familiar already. So in here is not indeterminate, but rather that's equal to 1. And so therefore we say that the limit of 3 to the 3 e to the x minus 3 all over 2x. So this one here is a typo. It should be like the initial given. That's actually equal to 3 halves. And so the lesson here is that the given function might look like something that is very, very complicated, but as you go ahead and look closer, you'll be able to find patterns that that we were able to initially establish in the previous lessons. And we're going to use that basically when we go to the next chapter, relative derivatives. The next lesson that we are going to learn is the special logarithmic limits, and then I'll be posting it as well in your LMS. That's it for me for now. Thank you for watching.